Assalamualaikum and good morning to everyone. My name is Wan Abdul Azim bin Wan Muhammad Fauzi from Group 8. Today I want to present my project titled High Voltage Insulator Overhead Line Testing. These are all my team members. So I present the introduction to for this project. Unplanned event and power outage can be minor annoyance or major loss. Power outages are more likely as the world electricity infrastructure grows. Insulators are essential to the power system and transmission lines, and contamination can cause distribution to flashover and a power outage. Inspect and maintain during the interval. A power cable use one of five insulator. High voltage above 33 kV required a thicker insulator for the adequate insulation. This project will design a 33 kV pin insulator type. Insulator can be made from a rubber, wood, plastic, mica, and else. Electrical system use glass, ceramic, PVC, satellites, and polymer. And the most common material that used is a porcelain, followed by the statite and a glass. So each shed is 2.5 cm to 7 cm thick and covered with a silicone to prevent a voltage leakage. And this design overcome the insulator electrical and mechanical stress. So I go through to the problem statement. First is a flashover is now the most prevalent type of failure that can occur in an overhead high voltage insulator. Flashover is brought on by transient voltage and manifests itself as a strange behavior when the air is contaminated or when there is an issue with the insulator. In the event of the flashover occurring for the first time, the insulator may be function, but when the second flashover takes place, the damage will be severe. As a result, the portion of the tower that function as insulator may enhance the performance of the insulator. So, this project objective first is to design and build a conceptual prototype model of a pin type overhead line insulator from recycled materials such as plates and bowls. To create a prototype that can withstand a stress voltage of at least 33 kV of continuous alternating current by testing it on a dry and a wet surface. So for the scope, the goal of this research is to create an insulator that can resist 33 kV AC voltage while employing recyclable and plate material. This project will be done by observing the performance of the insulator with the mixture of recyclable material. So for the outcome final work, in order to the project to be successful, the final prototype model has to be able to endure high voltage of at least 33 kV alternating current. The effectiveness of the insulation is important to the fulfillment to this job. The performance of the insulation is determined not by the type of the insulation, but it also by the quality of the mix of electrical insulating material. So lastly, the initiative aims to achieve this objective target in order to be successful. That's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Sharafil bin Syafruddin. So we'll explain on methodology of the prototype construction. So when we start the project, we do some research on the insulator property and the material used. So this is the most important task that we done first, as we need to know what material that we need to use to withstand the 33 kilovolt insulation test. And then after the research being done, the material being selected to design the insulator, then the design prototype we designed the prototype based on the specification that being asked from the lecturer. As you can see at the report assignment, we have show the specifications such as the length must be 50 centimeter, the creepage distance maximum 70 centimeter, and others. And then after the design of the prototype done by using AutoCAD, then we propose the design to our lecturer. If the design pass, then we can move to the next step, which is prepare and making the prototype using the design. And if not, we need to propose a new design. So for our team, the first design not rejected, but it not follow some specification, as the creepage distance have some shortage around 20 centimeter. So we need to develop a new design, and then we extend our design from the using a bowl only. We're using a plate, bowl, and also cup. So by using this material, we can increase our creepage distance. So that's why we changed the design into a new design. And after we propose a new design, the design select or approved by our lecturer, then we prepare and making the prototype using the design. So for the making of prototype, we buy the material all using our to the nearest shop. We don't we don't make any order. All is ready made by. So we buy at the DIY hardware, and then we do the um, what we call that. We do the prototype step by step as shown in the methodology. So the prototype takes some time as we to develop, as we use silicon. So silicon takes some time to make it hard and solid into turn it into a solid state. So around 3 days we done the prototype. So after prototype developed, we test the insulator at lab, then the process, and by the result. Data being collected and the data shown by my other team members. So that's all from me. Thank you.
Okay, Assalamualaikum. My name is Muhammad Taramis Hairul bin Abdul Hamid James, and I will be presenting about the technical summary and also the costing summary for our project. Okay, as you can see at the picture that I attached at the slide, we can see that it is a fully and finished prototype for our project. Our project basically was made of PVC pipe, plastic plate, plastic bowl, plastic vase, and also J-hook. So why PVC pipe? Because PVC pipe acts as a good electrical insulator and has a good electrical treeing resistance. It is also act as a rod in the overall design of this prototype. This design allows that the rod to withstand large weight strain. PVC pipe also inexpensive and lightweight material, which contain a great level of chemical resistance. This PVC pipe also has a high surface hardness and greater abrasion resistance when compared to other material. So after that, we at the end of the road, we wrap with a heat shrink, because it will endure the heat, since it will be absorb the heat transfer. Also, we put grease. We place it inside the opening and then covered with PVC pipe. In addition, the silicone was positioned at the inside the ball and the vase. Because of this characteristic, it is possible to make sure of the material is insulate more electrically conductive material at greater voltage. So as you can see at the end of the rod also, we choose a metal hook, because it is excellent material for sustaining the insulator when its strength increase as a result of the weather condition. So we go to the costing summary. Okay, as you can see, this is our costing summary with total 68 ringgit and 50 cent. We can make an insulator which can sustain until 37 kilovolt high voltage. So that's all from me. We go to the next presenter. Thank you.
Assalamualaikum, and my name is Muhammad Coordination, metric number CN190136. I will continue with my group mate presentation. My part is laboratory HV testing. The high voltage laboratory, also known as the high voltage lab, may be found on the ground of the University of Tun Hussein On, is home to the School of Electrical and Electronic Engineering. The high voltage laboratory was created for teaching reason for students in both the undergraduate and master degree program. The laboratory is outfitted with brand new and cutting-edge piece of equipment. The laboratory is also available for use in this project and offer facility for carrying out experiment and testing relating to high voltage and insulating system. Next is high voltage testing procedure. Before we do the experiment, we need to know the procedure of testing. During operation, electrical equipment need to be able to resist over voltage without being harmed. Therefore, we need to make sure that this is carried out by developing an adequate testing plan. The testing of high voltage may be broken down into two distinct categories: the testing of insulation material, sample of the electric, and the testing of finishing equipment. The measurement of capacity, the power factor or the total dielectric loss, the ultimate breakdown voltage, and the flashover voltage are the tests that are done on complete piece of equipment. The breakdown voltage tests on complete equipment are restricted to just a few samples owing to the irreversible damage and destruction that it causes to the equipment, preventing it from being utilized again. However, in order to ensure that the equipment can withstand a certain voltage without being damaged when it is being used, it is subjected to a withstand test in which the voltage that is applied is approximately twice as high as the normal voltage, but is still lower than the voltage at which it will break down. The measurement of permittivity, the electric loss per unit volume, and the dielectric strength of the material are the key components of the battery of tests that are conducted on sample of the electric material. The first two are possible to be tested with the aid of the high voltage sense bridge. Okay, next is prevention and protection to ensure the experiment will conduct safely. First is sufficient clearance. Experiment required clearance, which means unnecessary items were removed from the area surrounding the experiment set to avoid a flashover. Two is hazard warning barriers. These were installed as a safety precaution so that no one could get too close to the high voltage during experiment. Next is interlock. To prevent any potential catastrophes in the lab, appropriate interlock have been installed to cut off the manpower in an instant. Next is discharge route. Inside of the testing area, discharge route is being installed in order to earth any piece of machinery so that they do not become a part of the circuit. That's all for me. Thank you.
Hi, my name is Shakimi bin Mahapunya, and I'll explain to you guys about the high voltage testing result. Based on the insulator prototype, we have made the testing, which is the high voltage testing at Batu Pahat. And then the insulator was completely based on the design that was proposed in the proposal, which is it is made up of a few materials such as PVC pipe, plastic dishes, bowl, vase, grease, and cement. And then the pipe, which act as a rod of the insulator, is filled with the grease and cement, and all of the prototype which was assembled was sprayed by using the brown color coating. During the high voltage testing, the terminals, the positive terminals will be attached at the hook of the insulator, which is at the top of the insulator, and then the negative terminal will be connected at the rod, which is at the center of the insulator. The testing is split into, which is the dry testing and wet testing. We'll proceed with the dry test. Dry test will replicate favorable weather. To begin the dry test, the insulator will be hung at the metal rod without any extra material, different compared to the wet test, which we will spray the salt water. And then the goal of the dry test is to replicate the environment that will be present when the weather is favorable to the insulator. And based on our group prototype, our insulator prototype, uh, we have the insulator can withstand the maximum of 37 kilovolt. And then the reasoning behind of the after the 37 kilovolt, the spark have produced, and the reasoning behind the spark is the original bowl doesn't have enough privilege to prevent the electric current from coming into contact with the next disc. Then we proceed to the wet test. The wet test, it will replicate stormy weather. To perform, before we perform the wet test, the insulator will be sprayed with the salt water, and then the salt water will be uniformly dispersed around the insulator on every angle and fold of the insulator. And based on the wet test, we have achieved 19 kilovolt before the spark emerge, and at the bottom of the section at the insulator. And when the spark emerge, the main power is instantly terminated for safety. And then before the insulator is removed, one of the representative was requested to enter the test cage for discharge procedure. I think that's all from me. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Iqbal bin Sabahat. Today I would like to present about testing at the laboratory and the recommendation. And for the laboratory high voltage testing, it which use University Tun Hussein On Electrical and Electronic Engineering Department. The laboratory is also available for use in research projects and offers facilities for carrying out experiment and testing relating to high voltage and insulation system. In light of the fact that this is regarded as a potential life-threatening lab experiment, several preventive measures and safety protocols have been put into place inside the lab in order to guarantee that the experiment may be carried out in a risk-free environment. Next, for the high voltage testing procedure, during the operation, electrical equipment has to be able to endure over voltage without being damaged. Therefore, we need to make sure that this is carried out by implementing an appropriate testing strategy. Second, the testing of high voltage may be broken down into two distinct categories: the categories of insulating material sample of electric and the testing of finished equipment. Third, the measurement of primitive The electric loss per unit volume and the electric strength of the material are the primary component of the battery of testing that are performed on sample of the electric material. The first two are able to evaluate with the assistance of high voltage carriage bridge. And last, the power factor or the total dielectric loss, the ultimate breakdown voltage and the flashover voltage are the tests that are performed on the finished pieces of equipment. The breakdown voltage tests on finished equipment are limited to only a few samples due to the irreparable damage and destruction that is caused to the equipment, preventing it from being used again. However, in order to ensure the equipment can withstand a certain voltage without being damaged when it is being used, it is subjected to withstand tests in which the voltage that is applied is approximately twice as high as the normal voltage, but is still lower than the voltage at which it will break down. Next, for the prevention and protection to ensure that the experiment were conducted safely, first, sufficient clearance. The experiment required clearance, which means unnecessary items were removed from the area surrounding the experiment sites to avoid a flashover. Second, hazard warning barrier. Cache were installed as a safety precaution so that no one could get too close to the high voltage during experiment. 3. Interlock. This is to prevent any potential catastrophes in the lab. Appropriate interlock have been installed to cut off the main power in an instant. And last, discharge road. For discharge road, inside the testing area, discharge road is being installed in order to earth any pieces of machinery so that they do not become the part of the circuit. And for the high voltage testing result, our insulator was also completely based on the design that was proposed early. The terminal are linked as follows. The positive terminal is attached to the portion of the insulator that is located at the top, and the negative terminal is connected to the part of the insulator that is located in the center. And for the dry test, over a course of time, the total wattage of the energy that was flowing into the insulator saw a slow but steady rise. Our insulator was able to tolerate the increased voltage up to maximum of 37 kV, but sparks were produced as a consequence of creepage. The original bowl did not have a big enough creepage that was appropriate for the preventing electric current from coming into contact with no visible alternation. When the voltage reached 37 kV, the main power was cut off for ground of public health and safety. Throughout the whole of the procedure, the insulator was monitored from the outside of the barrier cage. And for wet test, before the commencement of our experiment, the complete insulator is being sprayed and coated with salt water. The water is sprayed separate uniformly. The water must be adjusted to be sprayed on every angle and fold of the insulator. The goal of the water is to replicate a stormy weather and the performance of the insulator when it's being utilized in this weather. When the voltage of the electricity reached just 19 kV, sparks began to emerge on the bottom section of the insulator and the main power is instantly terminated. This demonstrates that the insulator that has been constructed is not be able to survive in humid or rainy circumstances that might lead to mishap. Before the insulator is removed out of the test location, a group representative was requested to enter the test cage for the discharge procedure utilize a red discharge. The goal of the discharge is to guarantee that no electrical current is left on the component test and the insulator may be removed safely. And for the recommendation of the project is to replace the material of the plastic to the porcelain material. And as we know, materials such as granite are often heated to temperature between 1000 and 1400 degrees Celsius in a fire to create the ceramic material known as porcelain. This is the big aim for the material to use the porcelain, that because the porcelain have the high restraint for the high temperature. Porcelain is the material that used most frequently for overhead insulator. Porcelain made the waste aluminum silicates. The final hard and glass porcelain insulator material is created by combining aluminum silicate with plastic chlorine, feldspar, and quartz. In order to prevent water from being traced on the insulator surface, it should be well coated to the material. Porcelain should also be devoid of porosity because this is what mostly causes the degradation of its dielectric property. Additionally, it might be devoid of any impurities in bubbles that might compromise the material's insulating qualities. That's all for me. Thank you.